It's me again, Sir Art, for the third topic, which is the operations on functions. Module 3 of Quarter 1 in the Senior High School General Mathematics. In this video, you will learn how to add, subtract, multiply, and divide functions, as well as the compositions of functions. In performing operations on function, it is just like the same on how to perform the four basic operations on polynomials. Functions with overlapping domain can be added, subtracted, multiplied, and divided. So let us now discuss the definition of the different operations on functions, which is the sum, difference, product, and quotient of functions. Given functions f and g, then if x is in the domain of f and g, the sum quantity f plus g of x is just equal to f of x plus g of x. The difference of the two functions, quantity f minus g of x, is just equal to f of x minus g of x. And then the product, quantity f times g of x, is equal to f of x times g of x. And then for the quotient, quantity f over g of x is just equal to f of x over g of x, where g of x should not be equal to 0 because it will make the quotient undefined. So let us learn from the succeeding examples on how to perform the different operations on functions. So example number 1, let f of x is equal to 2x minus 3 and g of x is equal to x squared minus 5. Find letter A, quantity f plus g of x, letter B, quantity f minus g of x, and letter C, f times g of x, letter D, quantity f over g of x. In this problem, letter A is just the sum of the two functions. Letter B is the difference. Letter C, the product, and letter D is the quotient of the two given functions. So let us answer letter A. That is the finding the sum of the two functions. The sum of these functions can be written f of x plus g of x, or as the quantity f plus g of x. So they are just equal because it is the definition of sum of functions. Quantity f plus g of x is equal to f of x plus g of x. And then we're just going to substitute the given values of f of x and g of x, wherein the value of f of x is 2x minus 3, while g of x is equal to x squared minus 5. Then the operation is just addition because we're going to get the sum of the two functions. So simplify by combining like terms. So therefore, copy x squared, then copy 2x. The operation is plus. Then negative 3 plus negative 5 is just equal to negative 8 by combining like terms. So the answer for the sum of the two function is just quantity f plus g of x is equal to x squared plus 2x minus 8. And the domain or the x values of the functions are all real numbers. So letter B, finding for the difference of the functions, the same given for f of x and g of x. So to get the difference of these functions, it can be written as f of x minus g of x, or as quantity f minus g of x. And then quantity of f minus g of x is just equal to f of x minus g of x because that is the definition of the difference of functions. Then substitute the given values for the two functions. F of x is 2x minus 3. G of x is x squared minus 5. Then we are going to apply the distributive property since they are inside in the parentheses. So it will become 2x minus 3. Negative 1 times x squared is negative x squared. Negative times negative 5 is positive 5. Then after that, we're going to simplify by combining or adding like terms. Copy negative x squared, then copy 2x. The operation is addition. And negative 3 plus 5 is positive 2. Therefore, the final answer for the difference of the two functions f and g is equal to negative x squared plus 2x plus 2. So the domain or the x values in this function are all real numbers. So let us proceed to letter C, which is finding for the product of the two given functions, f of x and g of x. So to find the product, multiply the two given functions, wherein quantity f g of x is just equal to f of x times g of x. Then substitute the given values of f of x and g of x. So after that, we're just going to multiply the two given binomial by using FOIL method. So 2x times x squared, that is equal to 2x cubed. 2x times negative 5, that is negative 10x. Negative 3 times x squared is minus 3x squared. Then negative 3 times negative 5, that is positive 15. Then after that, we're going to combine like terms. So the final answer would be, since there's no like terms in the product of the two polynomial, we're just going to rearrange by descending order. So it will become 2x cubed minus 3x squared minus 10x plus 15. So that is the final answer for the product of the two polynomials, of the two functions rather. So the domain or the x values of the functions are all real numbers. And for the last item in number 1, that is finding for the quotient of the two functions, the same given value for f of x and g of x. So to find the quotient, divide f of x by g of x, and that can be written as f over g of x or f of x over g of x. And that is the quantity of f over g of x is just equal to f of x over g of x. That is the definition of quotient of functions. Then substitute the given values of f of x and g of x in f of x over g of x. So which is the given value for f of x is 2x minus 3. The given value for g of x is quantity of x squared minus 5. So we cannot divide, or there's no factor that can be eliminated. So it is the final answer, but the denominator should not be equal to positive, or the value in the denominator, since there's x, we're going to exclude the value of x, which are the positive and negative square root of 5. Since in dividing the polynomials, we write x should not be equal to positive or negative square root of 5, because these values would make the denominator 0. And the function f over g of x undefined. So let's proceed. So the domain of the quantity f over g of x is the set of all real numbers except for positive and negative square root of 5. So let's proceed to example number 2. If f of x is equal to 3x plus 2 and g of x is equal to x squared plus 3x minus 4, find letter A, quantity f plus g of x, letter B, quantity f minus g of x, letter C, quantity f g of x, and letter D, quantity f over g of x. The same for in number 1. So to find for letter A, the sum of the two functions, we're just going to write f of x plus g of x, or as f quantity f plus g of x, and equate that to notation because that is the definition of the sum of functions. Then substitute the given values of f of x and g of x, wherein f of x is equal to 3x plus 2 and g of x is equal to x squared plus 3x minus 4. Then after that, we're just going to simplify by combining or adding like terms. So copy x squared, then add 3x plus 3x, which is 6x, then add positive 2 plus negative 4, which is equal to negative 2. Therefore, the final answer for the sum of the two functions, f plus g of x is equal to x squared plus g of x minus 2. So the domain or the x values of the functions are all real numbers. And for letter B, the difference of the two functions, the same given values for the two given functions. And to find the difference of these functions, it can be written as f of x minus g of x or as the quantity f minus g of x. So write quantity f minus g of x, it is equal to f of x minus g of x. Okay, that is the definition of the difference of functions. Then substitute the given values for f of x and g of x. Then after that, to remove the parentheses, we're going to apply the distributive property. Copy 3x plus 2 and then multiply negative imaginary negative 1 inside the parentheses. That will become negative x squared minus 3x plus 4. Then after that, simplify by combining like terms. Since here, 3x and negative 3x are opposite signs, therefore it is equivalent to 0. So we're just going to copy negative x squared and then add positive 2 and positive 4, which is equal to 6. Therefore, the final answer for these two functions or for the difference of these two functions, f and g, so quantity f minus g of x is just equal to negative x squared plus 6. And then the domain or the x values of the functions are all real numbers. Then for letter C, which is the product of the two given functions, to find the product, we are going to multiply the two given functions. So f times g of x, it is just equal to f of x times g of x. And then that is the definition of product of functions. So substitute the given value for f of x and g of x. After that, we're going to multiply the two given polynomials. So 3x times x squared, that is 3x cubed. 3x times 3x, that is 9x squared. 3x times negative 4, that is negative 12x. And 2 times x squared, positive 2x squared. 2 times 3x, that is positive 6x. 2 times negative 4, that is negative 8. Then after that, simplify by combining or adding like terms. So copy 3x cubed, then 9x squared plus 2x squared, that is 11x squared. Negative 12x plus 6x, negative 6x, then copy negative 8. Therefore, the final answer for the product of the two given functions is 3x cubed plus 11x squared minus 6x minus 8. So the domain or the x values of the two functions or the given functions are all real numbers. And then for letter D, finding for the quotient of the two functions, the same given. To find the quotient, divide f of x by g of x. That can be written as quantity f over g of x or f of x over g of x. So quantity f over g of x is just equal to f of x over g of x. That is the definition of quotient of functions. And then substitute the given values for f of x and g of x in f of x over g of x. So f of x is 3x plus 2, g of x is x squared plus 3x minus 4. Then after that, divide the polynomials, these two polynomials. And we are going to write x not equal to 1 and negative 4 since we're going to factor the denominator and that values should not be included in the domain. It is because those values would make the denominator equal to 0 and will make f over g of x undefined. So therefore, the domain of f over g of x is the set of all real numbers except 1 and -4. So let's proceed to the composition of functions. Given the functions f and g, the composition of f and g denoted by f circle g is defined by the equation quantity f circle g of x is equal to f times the quantity g of x, where f times the quantity of g of x is read as f of g of x. It means that wherever there is an x in the function f, it is replaced with the function g of x. The domain of the quantity f circle g is the set of all x such that x is in the domain of g and g of x is in the domain of f. So let's apply that to the following examples. Example 3. Given f of x is equal to 3x minus 5 and g of x is equal to 2x minus 3. Find letter A, quantity of f circle g of x, and letter B, quantity of g circle f of x. So since quantity of f circle g of x means f of g of x, we must replace its occurrence of x in the function f by g of x. So that's since in answering letter A, we will first write the given equation for f, which is f of x is equal to 3x minus 5. And then since the what is asked in letter A is f circle g of x, which is equal to f of g of x, okay, wherein it is the definition of the composition of functions, then after that, we're going to replace x in the given equation for f, 3x minus 5 by g of x. So it becomes 3 times g of x minus 5. And then replace the g of x by the given value, which is 2x minus 3. Then after that, simplify by distributive property or distribution law. 3 times 2x, that is 6x. Then 3 times -3, -9. And copy -5. Then simplify. Copy 6x. Then -9 minus 5, that is -14. So therefore, f circle g of x is just equal to 6x minus 14. So let us answer letter B. It's the same given value for f of x and g of x. So letter B is find g circle f of x. Since g circle f of x means g of f of x, we must replace its occurrence of x in the function g by f of x. So let us copy g of x, which is equal to 2x minus 3, the given equation for g. And then define the composition of function, which is g circle f of x is equal to g of f of x. And then replace x by f of x. So we're going to replace x in g of x by f of x. That becomes 2 times f of x minus 3. And then replace f of x by the given value of f of x, which is 3x minus 5. And then apply the distribution law. 2 times 3x is equal to 6x. 2 times -5, that is -10, and copy -3. After that, combine like terms. Copy 6x, then -10 minus 3, that is equal to -13. So thus, g circle f of x is equal to 6x minus 13. So That's it for Module 3, the operations on functions. I hope you understand how to perform the different operations on functions, including the composition on functions. So again, thank you. This is Sir Arthur Lawrence E. See you on the next video tutorial.